Force required to move a wooden block. Newton's second law of motion is one of the three laws of motion published by Sir Isaac Newton in 1687. The law explains the interaction of forces and objects and the way in which the motion of an object is affected by force. Newton's second law of motion can be formally stated as: the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. That is, an object of mass m subject to an unbalanced force F will have an acceleration a in the direction of the force. For a given mass, the acceleration of the object will be larger for a larger unbalanced force. To achieve a given acceleration, the force required will be larger for an object with more mass. This is represented mathematically in the formula force equals mass time acceleration, which is F is equal to ma. Some of the daily life situations that illustrate the second law are kicking a ball and up and down movement of an elevator in a building. Newton's second law, F is equal to ma, enables us to calculate the force F, which is required to accelerate an object of mass m with an acceleration a. Materials required: a block of wood, spring balance. Procedure: first, arrange a block of wood and a spring balance on a table. Take the spring balance and note the least count of the spring balance. For 5 divisions, it is 0.25 n. That means for one division, it is 0.25 divided by 5, which is 0.05 n. Now, fasten the spring balance to the block of wood. Then, pull the spring balance. As the spring balance is pulled at a particular force, the wooden block just starts to move. Note the force in the spring balance. It is found that as the mass increases, the force required to move the block also increases. Thus, we have learned Newton's second law, which states an object of mass m subject to an unbalanced force F will have a constant acceleration a in the direction of the force. This is represented mathematically as F is equal to ma. We also observed that for a constant acceleration of an object, the unbalanced force applied will be directly proportional to the mass of the object. For objects with larger mass, we need to apply a larger unbalanced force to get the same acceleration.